Welcome back to the second video in this series on hacking SSO. In this video, we're going to get into a high-level overview of topics presented, as well as how to analyze SAML traffic with burp plugins and identify key parts needed for our attacks. The first thing we have to understand is what SSO is. The simplest way to explain it would be that it's a single sign-on solution which we provide credentials to, and it allows us access to a lot of resources from various service providers using an authentication token. For example, I'm sure you've all seen something like this before. A login prompt with a Google or Facebook option that, if used, provides access to that application's resources. This is SSO, which could come in the form of OpenID, OAuth, and SAML. In the case of SAML, the way it works is that we browse to the service provider's application page, at which point we are redirected to an identity service provider with a redirect URL. The identity provider will check their credentials and provide an assertion token. We take this assertion token and provide that assertion token to the service provider, who will then provide us access to their resources. During the recording of this video series, pentesterlab.com was nice enough to provide a SAML Lab, which I subsequently incorporated into the video series. So you could try some of the stuff yourself without setting up servers and coding your own SAML logins. This will provide you with a way to analyze some SAML traffic and perform one of the SAML attacks presented in this series. If you've never used pentesterlab.com before, I highly suggest it, as it's an excellent resource to learn web application-based penetration testing. I will also refer to this website for some of the XML-based attacks, such as XXE, which will give you an opportunity to work through some of these attacks, as well as an excellent resource in the future. I already have a burp proxy set up with this browser. Let's run through this lab in our burp proxy and take a look at the traffic in order to determine how to identify SAML traffic and how to use some burp plugins to aid our analysis and attacking phase of our assessment. The first thing we'll do is register a user with identity provider because we don't have one. We'll use the username test3@test.com with the password testing. Once this is complete, the application automatically logs us in. It's just the way it works on this lab. So let's take a look at the traffic. This first request, ending in 5C in the URL line, appears to be our registration, sending our username and password to the identity provider. Next is our redirect to our identity provider with the SAML request. You can take a look at that here decoded. We then receive our assertion token, and we send that in a SAML response to the service provider located at 6.3 in the URL line. This is a base 64 encoded value. We can decode that and take a look at it here. The reason I have a tab here called SAML is because I have a few burp plugins installed which are very helpful when dealing with SAML traffic. The first plugin I have installed is called Espresso. It captures various traffic from other SSO implementations such as OpenID, OAuth, and in this case SAML. SAML is captured right here, and you'll see in the last line, here's our request to the service provider. And here's another tool called SAML Rater. Just like Espresso, SAML Rater decodes the traffic shown in the bottom pane. It also includes stuff like XSW attacks and various implementations of XSW attacks for different types of formats. You can also remove signatures and mess around with certs. Now let's take a look at the actual assertion token associated with the attacks we're going to perform. Let's hop over to the SAML tag, just because it doesn't have the extra pane up top and we can get a better view at what we're looking at. The first thing you'll notice that this is XML. Because this is XML, it is therefore susceptible to XML-based attacks. We won't get into live examples of XML attacks, for example, external entity injection, XXE, or recursive XML attacks, coined billion laughs, because they are well known and documented. We will instead focus on SAML-specific attacks. However, I will place a link to an online lab below for XXE so you can get some practice with XML attacks, and briefly give an overview of their key points for you to explore in the links below. You can easily apply your knowledge gained from the links to the lab to a SAML target. With an XXE attack, you are simply using built-in functionality regarding the document type definition DTD to take advantage of weakly configured XML parsers and execute external entities in order to define new entities, which essentially embeds content in the body of the response. Kind of like creating a variable in programming and then calling that variable somewhere else, which could be leveraged to print system files and responses or executing code with PHP modules like expect. This can be done by calling local files on HTTP servers, or even SMB on local network. I am sure you can think of all kinds of likely attack scenarios with this available functionality. On the screen here, you'll see an entity, test, calling system file cboot.ini. Below that, you see an end test. When the end test is hit, it takes the contents of boot.ini and places that within the body of the response. You can see under XML attacks a couple other ways to call files over HTTP or SMB. If you'd like to try this attack and get some experience, check out the link in the notes below. Shown here is the billion laughs attack. This is a recursive XML attack used to allocate an abundance of resources and create a denial of service situation. It was coined the billion laughs attack based on the use of LOL shown in the picture. If you look at the defined entities, you will see 9 entities defined, which each call the preceding entity multiple times, which then call those entities multiple times until you have a billion laughs and way too much memory allocated. In the body of the XML, you will see LOL9 called, which then trickles down the waterfall, triggering all of the recursive calls to LOL. As you can see, the billion laughs attack is pretty easy to implement. That covers the key points I wanted to show in this video. In the next video, we will cover analyzing SAML assertion tokens, the XML structure, and how they are used in various SSO attacks. Thanks for watching. If you learned something, hit the like button below this video. If you want to keep up to date on new video releases, make sure to subscribe to this channel and check out any other resources in the links below, including the Console Cowboys blog associated with this series and any links for labs associated with this video.